So good morning, good afternoon, good evening, wherever you are in the world. Dear authors and invited guests, it is my great pleasure to welcome you to the 6th International Congress on Information Community Technology through Zoom on behalf of ICICT 2021 and Global Knowledge Research Foundation. As every one of us is passing through unforeseen circumstances as a result of COVID-19, we wish everyone and their families a safe time and hope we all pass through this soon. Further, with immense happiness, I would like to share that we have received an overwhelming response this year from over 90 countries, where 1,150 papers were received and 350 papers have been accepted, contributed to the success of the conference, and the papers will be published in 4 volumes this year. We are thankful to all of our guests present on the platform to join us digitally for the conference in these unpredictable times and make this conference more fruitful in terms of technical knowledge, and hope you enjoy the 2 days of knowledgeable and interactive sessions. Before we get started, I would just like to welcome you to our chair for this session, which is Professor Pukolski from the University in Polkowice in Poland. Mr. Pukolski will just be overseeing the presentation and be asking yourselves a few questions after you've finished. So, to begin with, we have our first presentation will be machine learning with meteorological variables for the prediction of the electric field in East Lima and Peru. Our presenter for this will be Juan Soria, who I'm going to try now and add to the, here he is. I will just unmute you quickly, sir. I've just asked to unmute you. Michael, I will unmute you briefly, but it's just basically struggling to hear you guys. Could you say that again?
There we go. Sorry about that.
Oh, no.
I think there's some difficulties with Dr. Soria with the presentation, but we're going to go ahead and get started. I'm the translator for this project, and so since there's some difficulties there, I'm just going to go ahead. If you don't mind, I'll share the screen here, share the presentation that Dr. Soria has prepared, and we can get started.
Very nice. Mute myself now.
Project. All right, I'm going to share screen. So will let me? Yes. There we go. To presenting, and then I can share the screen. There we go. There we go. Make sure everyone can see the screen all right. So thank you on behalf of Dr. Juan Soria and the rest of the team. I'm going to be presenting machine learning with meteorological variables for the prediction of the electric field in East Lima, Peru. The team members here, this was a project through various disciplines. We've got engineers, we have mathematicians, we have more on the computer science side, and we even have a student who joined us, and I am here as the translator for this group. So here are the members. Most of them are here in the Zoom room right now. So welcome everyone. And in this project, the main problem here is that we're trying to measure the impact of different meteorological variables, things like the temperature, UV radiation, and how those affect the Earth's magnetic field. Because what we're finding, and basing on some earlier publications, that the whole Earth and the system is sort of like a big conductor. And when we measure these variances, these changes in the Earth's magnetic field, we found that there seems to be some sort of a correlation with these meteorological variables. So the goal here was to measure it, but then to develop a model to help predict the magnetic field based on some of these meteorological variables. This is the study center. This is the main campus of the Universidad Peruana Unión, or Peruvian Union University, here in Lima, Peru. And 2 main sensors were used to gather all of the data during the whole year of 2019. So this gives a brief idea of where it is, this area in East Lima, Peru. And we use the Vantage Pro 2 meteorological station to measure the main data like the UV radiation and the temperature. And we use that in this model. This is what sort of explains the model here in this figure. That we start with our, in the bottom part here, we start with our meteorological data and the electric field. We go through a consolidation process into a machine learning model. All of this data is then analyzed and uses inputs, and we have the display and a learner regression, this software through the MATLAB program, in order to try out different models. And that was the main focus of this study, to see of the different machine learning models available, like the find free, the ensembles, the Gaussian process, to see which could give us the best predictive model. And that's what we see. Well, sorry. Here we've got the electric field measurements. This is the instrument installed on the roof of our campus. Right now here in Peru, we're all online for education, but this is installed in our university campus, and the data was taken from before the pandemic started. So we're able to get a lot of data points, over 1,500 data points, to use as inputs to build and test this model. Here it is, the map here. The instruments are installed on the roof of the engineering building here within our university campus. So we found with this part, the Regression Learner app, as part of MATLAB, gives us a lot of options. We found the best results with the Gaussian process regression models, but we tried several, including the regression trees, support vectors, the ensemble of trees. Of all of these, we found this model that worked out well for us. So a brief description of what exactly it's doing. We trained it using the fit-RGP function within MATLAB, and we have the formula here detailing what the training set looks like, where we split our data into a training set and a validation set. And here, our linear regression model, the form that it took here, to explain the response by introducing latent variables from a Gaussian process, an explicit basis function, H. The covariance function of the latent variables captures the smoothness of the response, and basis functions project the inputs, X, into a p-dimensional feature space. So here we have a little bit more of a description, and can be read further in the article, of the model, the specific Gaussian progression model that we use, and how it's defined here with its covariance function and the Gaussian process. And taking this model, we now have our GPR model, which is the basis for the rest of this study and for its results. Because we needed to take in all of the latent variables, trying to take in as much data as possible in order to better predict. So here we have the results. We're basing the measurement on RSME, trying to find the lowest RMSE possible based on the input variables that we have, things like temperature and UV radiation. And here we have the results. We let the models run for 6 hours. And at that cutoff point, these are the RMSE values that we found. So they're ranked here in order, we could say from worst to best, with the fine tree models giving us about 1.38. And we finally got down to the Gaussian process regression models with rational quadratic to an RMSE of 1.3435, which is the lowest value that we found. And also here in this table, we include the R squared, the MSE, and the MAE to give a little better idea. But this was the optimal prediction model that we found of the maximum temperature with electric field. Looking at these two variables for now. Here, the box and whisker plots help us express this a little bit better. We have it divided here by seasons. Here in Lima, we're close enough to the equator that the seasons aren't very different, but they do have enough of a marked difference that we can see here in this figure, for example. We're looking at predicting the electric field. Starting on the far left, we have in the winter, then into fall, then summer, and finally spring, with the residuals here on x-axis. And these 4 main time periods show that there's a bit more irregularity, a bit more outliers here in the winter, and things are generally more condensed, more closer to the middle here in the middle of the year in spring and summer. These figures are what best shows how the predictions match up with the real data. Here in the middle, the yellow part, we have the predictions based on the model, the GPR model, and the blue dots then are the actual data values. Here we're looking at maximum temperature in this particular graph in the x-axis, and in the y we have the response, the electric field. So you can see the good thing here, what shows the good predictive abilities of this model, is that all of the yellow points, the predictions, are within the real data, the blue points. As we notice in the box and whisker plots, there's a bit more variation earlier on in the year, in the winter, but especially as we get into the middle of the year, the blue dots are much more condensed and we have a better prediction. And here in this one, we have a similar graph, but here we're looking at UV radiation, solar radiation. And here it's even closer aligned, the yellow part or gold that's prediction, and the blue dots that are the real value. Here as a scatter plot, it is a little bit easier to read. Here the same information about UV radiation versus the electric field, and see how the electric field is more varied earlier on in the year, and then as it gets a little closer together near the end. So here, the main results that we're looking at is that applying machine learning in this study, we're able to develop a prediction model using meteorological variables in relation to the electric field and estimated through the regression learner app models to obtain the highest accuracy. You can say the Gaussian process regression model with maximum temperature and UV level. In other words, these are the two meteorological variables that had the most correlation, that were best suited to predict the electric field, maximum temperature and UV level. Some of the other variables that we considered in the study, like wind speed, you can find them in the full report. Here they're not mentioned because they weren't as correlated as maximum temperature and UV level. And we find their RMSEs of 1.3435 and 1.3410 respectively. The other main variable we're looking at here that is somewhat related, solar radiation, was at an RMSE of 1.3820. But the interesting part about solar radiation is that the Gaussian process regression model was not the optimal model for solar radiation. In that case, it was actually through the regression tree model.
Sorry to interrupt, just 2 minutes left, please.
All right, yeah, that's perfect. We're coming here, the bibliography you can check out for our work, and wanted to thank you for the participation. Sorry about the confusion there, a little bit of difficulties with Zoom, but hopefully we're going to see how we can relay any questions you might have to the team and find a way that we can get an answer for you.
Yeah, I'd probably just like to invite the chair just to ask a few questions if he has any.
So any questions from audience, please? You can write on the chat. So I have a question. So could you show me again your references, please?
Oh, certainly. Yeah, let me share the screen again.
Okay, so it was very interesting presentation, but I have one question. So I see that you have used some references from 2007. Show me next slide, please. And from 2009, 2004, 2002, could you explain me why have you used references from, which are, in my opinion, not up to date? Of course, sometimes is required, but I'm just wanted to know.
All right, let's see. Sorry, the connection with the rest of the team isn't really working that well. What we can say is that the core theory, we could say, of the Earth as a conductor was best expressed, or kind of originally expressed, here in this first citation from 2007 by Bennett, and then Bennett developed it a little bit more. So we included some later sources, some more recent sources that also make reference of this model. But since it was originally explained or originally developed in this article in 2007, it's only fair to give credit where credit is due to the original author of this model of the Earth's electric field. But some of the other references that are certainly much more recent, like references 5 and 6 here, developed that model more in more recent years.
Okay, thank you very much. Any questions from audience, please? Okay, thank you very much.
Right,
Thank you very much.
Thank you for that. Just to move on now. Thank you for that, guys. For our next presentation, by Aji Gautama Prajala, sorry if I said your name wrong there, for the presentation of evaluation of face detection and recognition methods in smart mirror implementation. I will just invite Aji to join the call now. There you go. I've just sent a request to unmute yourself. There you are.
Hello, Mr. Liam.
Hello.
Liam. Did I pronounce it right?
Yeah, Liam's fine. Yeah.
Yeah. Okay. Thank you. Let me introduce myself. My name is Aji Gautama Putara. I think I'll start immediately with my presentation.
Yeah. Go ahead.
Okay. Thank you. So I've prepared a video for my presentation. I hope it will make it more fluent. How are you? Let me introduce myself. My name is Aji Gautama Putrada. I am here to present my research called Evaluation of Face Detection and Recognition Methods in Smart Mirror Implementation. Let me start my presentation. Let me start with the introduction. The smart mirror is a mirror with electronic display and has additional capabilities like showing weather and others. The technology involved in smart mirror are usually embedded systems because we use a camera to detect face and image processing. Here we will use the Raspberry Pi for the microcontroller. Example implementation of smart mirror. Here we are using a case for child documentation to prevent the loss of children. There are two image processing methods that are used, which is hard cascade and local binary pattern, or it's usually called LBP. Based on the introduction that I just gave to you, our research aim is to implement a smart mirror that can detect and recognize face with the help of Android apps. And secondly, we will analyze the Pearson correlation of some presumed-related factors to determine the metrics of image processing.
Sorry to interrupt. A few people are struggling to hear you. Is it possible to increase the volume on your computer or anything? I just about, but apparently few people are struggling.
I think that's the maximum value. I will probably just give a direct presentation.
Okay.
I'm sorry.
Yeah, sorry about that.
Okay. So this is my PowerPoint. Okay. Okay, I'm prepared enough. Based on the sorry. Okay, so the first research aim is to analyze the significance and difference of the performance of LBP and R cascade. I'll go directly to the architecture of my system. Here we are using a Raspberry Pi for the mini computer of my system. The Raspberry Pi is connected to a TV. The TV will display some information to the mirror. The mirror is a one-sided mirror, so it can reflect the TV to the user. Here we use a Logitech webcam to detect face and recognize the face automatically. We are using a database to connect the data with the Android apps, and we have an Android apps to receive face pictures of the users so we can communicate with the smart mirror. Okay, I think that's it. And this is the process. Picture of the smart mirror. Um, so to start is we take a photo with the Android apps, and then we send it to the database, and then the Raspberry Pi will receive it from the database, and we will do training here. There is training, data training, and then the Raspberry Pi will analyze the face and will authenticate the face and give results if the face is valid or not. It will be then reported to the database again, and the Android apps will receive the data from the database, and the user can know if he is a valid user or not to the smart mirror. Okay, and then so based on the objective of our sorry, I think you can still listen to me. Okay, I'll continue with my presentation. We have some presumed things that we think that are related to the factors that we want to test. For example, object movement. So we presume that if the object is moving and if it is not moving, it will be related to the output factors of our research, and then the number of dataset will also be an important factor. And the last one, the number of objects being tested at the same time. So 5 phases at the same time, 3 phases at the same time will affect the output. And then we use Pearson correlation to see if there is any correlation between the things that we presumed and the performance that we measure. And then we want to compare the LBP and the Haar cascade directly. We want to see if there is a significant difference between LBP and Haar cascade. So we use the t-test. This is the t-test equation. And this is the system that we have successfully built. Here at the left, we can see the mirror from the front side. We can see the reflection of the users, and we can see the information that is printed at the television, the 24-inch television. And at the top side of the mirror, we can see there is a webcam. And then the middle picture shows us the rear view of our system. The webcam at the top and the TV at the middle and the Raspberry Pi at the below. And then lastly, at the right side of the image, we can see the application that the user is using, and we can see the output is the face recognition and the face verification of his face. Okay. And then these are the metrics that are being tested. First is the percentage of the recognized face and the identified face. Secondly is the face that are not identified, and then the false positive rate, and then the recognition runtime, and lastly the dataset training runtime. Okay, these are the results of the Pearson correlation. Pearson correlation says that if the value is larger than 0.5, means that there is a correlation between the dependent value and the independent value. Here we can see that the only one that is larger than 0.5 is the number of objects compared to the face recognition runtime. So all of the rest are not correlated. We will only compare them with significance tests and the t-test. Okay, this is so previously we said that the runtime is correlated to the number of phases. Here we can see there is a correlation that when there are more people detected, the runtime will increase. And here we can see in the bar chart, the blue one is the hard cascade and the red one is the LBP. In the left side, we can see that the LBP is larger than the hard cascade, but at the end of the bar chart in the 5 people tests, the hard cascade becomes larger. Okay, and this is the, sorry. Here we can, this is the results of the recognition test and the false positive test and the not recognized test of LBP and hard cascade. We want to see if the results are significantly different or not. So we use the t-test, and this is the t-test. Here we can see the t-test concludes that in each of the tests, well, although the data is different, but they are not significantly different. So we conclude that hard cascade and LBP doesn't have a significant difference in the performance. I think that concludes my research. So we have 3 conclusions. The first one is that we successfully implemented a smart mirror with Android apps and Raspberry Pi. And then secondly, we have seen that the runtime has a correlation with the metrics that we measure. And lastly, we don't see that there is a significant difference between hard cascade and LBP. I think that's the end of my presentation. Thank you for your attention. I'm sorry for all the limits of my presentation. Mr. Liam.
Yeah, thank you very much. Just invite the chair, just if he has any questions that he'd like to ask, or if anyone else would like to ask a question, just to write it in the chat. Any questions from anyone?
So I have a question. So I've noticed that you have used an Android system. Could you tell me something more why you have chosen Android system and what about another system?
Okay, so thank you for your question. I think my easy answer is that here in Indonesia, Android application is free and is open.
Oh, okay.
Yeah, and so students like to use Android apps here. Thank you for your question, sir.
Thank you very much.
Any more questions from anyone? Right, well, it would appear not. So to move on, we were planning to go on to the next presentation, which would be proposal of a methodology for the implementation of a smart campus, but it does not look like Gladys has joined the meeting yet. So I'll wait just a second just to see if she joins, but if not, and if no one is here to present in her absence, then we will have to move on to the next one. I'll give it 30 seconds or so just to see if anyone joins or jumps to Gladys's aid to take over. However, it is not looking very promising at the moment. So, oh, Brian, it looks like the next one, no one is here either. So, is anyone here? Now we'll try to move on to the next one. Is anyone here who's able to present for George Ordonez on the presentation LDA algorithm for identification of topics, a case of study in the most influential Twitter accounts in Ecuador? It does not appear that George has joined the call. So again, I think we may have to move on. Right, the next one. Oh, I don't have this here either. So moving on now to the third one. would be linking the linguistic resources using graph structure for multilingual sentiment analysis. Mohammed Rauf Kanfood is meant to be presenting, but it doesn't appear that he is in the call either. Is anyone here to take his place? If so, if you could just type in the chat. Oh, doesn't look like anyone's here for that one either. All right, okay. Well, moving on to the next one then. So the next one that we are hoping to do is a presentation on the development of an augmented reality application as support and antenna characterization. The presenter is meant to be Tatiana Jarakuto, who also does not appear to be here. Is anyone else here in her place? Okay. All right, well, as there's so many absentees, this looks like this could be the last of the presentations. The last one would be reference method for load balancing in web services with REST topology using edge root tools. The presenter is meant to be Edwin Casey Kunto. However, they also do not appear to have joined the event. So unfortunately, guys, what we're going to do is we're just going to wait a few minutes, hope that someone joins in the hope that we can get a few presentations going, because as of yet, there is no one else who's joined the call who's meant to be presenting. So we'll just wait a few minutes, hope that someone joins. And then if not in, say, 2 minutes or so, then unfortunately, that will likely be the end. But yeah, we'll just wait here for a couple of minutes, guys. Right, guys, I'm really sorry, but unfortunately, we cannot get hold of any of the other we can't get hold of any of the other presenters. So I have a few closing remarks just to say. Obviously, this hasn't gone as planned. We are hoping for it to go on for a bit longer. I'll just quickly make a few remarks, and then afterward, we could get you to just turn your cameras on so we could get a screenshot. But just quickly, I've just got a few closing remarks. I'd just like to, oh, someone's joined.
Okay, can you hear me?
Well, I think this is this George Ordonez? I believe so. I'm just going to unmute. Hi, Osmani, I've tried to unmute your microphone. Are you here to present? Oh, there he is. George, we're just trying to unmute you.
George, yeah, I see him.
Hi,
George. Hello. How are we doing?
Okay. Yes.
Are you ready to present, George?
Yes, I am ready.
Okay, I'll just stop sharing my screen, and then if you'd like to share yours. I'll just quickly introduce what George will be presenting. His presentation is on the LDA algorithm for identification of topics, a case study in the most influential Twitter accounts in Ecuador. So thank you. I'll hand over to you now.
I start the presentation?
Yeah, please do. Please start, yeah.
Okay. Okay. Can you see the presentation?
Yeah, we can do.
Okay. Hello, everyone. Welcome to the presentation of the paper, the LDA algorithm for identification of topics, a case of studying the most influential Twitter accounts in Ecuador. This work was carried out by a group of researchers from the Universidad Politécnica Salesiana from Ecuador. The agenda for today is the next. In first place, the word motivation, then introduction and related words, then what and how did we do it, the results, the conclusions and future words, and finally the reference. The word motivation for this work. The environment in which we operate has undergone various changes, all motivated by the constant development of the ICTs. For this reason, today it's common to interact through social networks and have constant use of them. Given this, the motivation to study social networks from a technical perspective arose. In this work, Twitter will be analyzed through the LDA algorithm. Uh, about the introduction and related words, today the use of the social network is common in our environment, and most of use have at least one. Within this medium of user publish and share opinions, information, or simply trivia on all kinds of topic, generating a large amount of information that can be analyzed. Analyzing and understanding this information is becoming one of the main objectives on companies and organizations, since they can know what is said about the specific topic. For content analysis within social networks, organizations have begun to focus their interest in the study of short text, specifically in the comments that are made, to know the valuations that are given of certain products or service. In our case, the message posted on Twitter will be analyzed. This, more than a social network, is classified as two-way communication platform and is currently one of the most used worldwide. In this context, the purpose of this paper is to carry out an analysis of the topics frequently used by the most influential Twitter accounts in Ecuador. This analysis will be carried out with the use of the LD8 algorithm. Um, on this subject, there are several works carried out from different perspectives. For example, in Night, they created an application on Android that extracts topics from Twitter according to location. For this, they use the LDI algorithm. The authors indicate that the existing methods provide a trend for a country or city and not for a tourist place or restaurant, among others. For their part, the authors of 10 have created a system to detect the emotion expressed in a tweet using the EDA algorithm and symbol conversion. With the help of these tools, the researchers try to predict a total of 5 emotions in the happy, angry, scared, sad, and shocked. As can be seen in the reference shown above, several use the LDA algorithm for different purposes. Topic detection is a well-known and studied issue in the big data world. For this reason, our work differs from the rest, mainly due to the data set with which the analysis will be carried out, and do the comparison between techniques of backup words uh, and the term frequency model. Okay. Uh, and then what and how did we do it? To carry out our research, we will first choose Twitter accounts with the largest number of followers in Ecuador. The last 3,000 tweets will be extracted from each of the accounts concerning the data of analysis. In a file with CSV extension will be created. For the final part, with the help of software made in Python, the pre-processing of the information will be carried out and the application of the LDA algorithm to obtain the topics. In, in the figure, we have uh, the process of our work. In first place, we have those Twitter accounts, most influential in Ecuador. Then created a database, pre-processing, and finally apply the LDA algorithm for obtain the topics. One of the most complicated tasks when performing data analysis is creating the database with which you are going to work. In this way, the first thing defined for our analysis is the 10 Twitter accounts with the highest number of followers in Ecuador will be chosen. In the one, table one, the Ecuador's most influential Twitter accounts. We have the Twitter accounts in Ecuador con more number of followers. With this, we created the database. The data set obtained is first preprocessed, and then the LDA algorithm is applied. When we refer to the preprocessing of data, we are talking about the process used to clean the documents. That is, eliminating punctuation marks, eliminating words that do not give more meaning to the sentences, and carry out the process of tokenization and stemming of each one of existing documents. Our case was different, since when working with tweets, this comes with a lot of young information such as links to web page, mentions to other Twitter accounts, emoticons, emojis, and other information that does not contribute anything to our analysis. For this reason, the first thing that was done was to delete all this information. Following this, the stop words removal process was performed. Words are now as stop words that do not have a meaning by themselves, but rather modify or accompany others. This group is usually made up of articles, pronouns, prepositions, adverbs, and even some verbs. Finally, the tokenization and lemmatization process was accomplished. The term tokenize refers to dividing the text into sentences, the sentences into words, and each of these words is known by the name of token. This process helps us to analyze which words go together with others and which of these are repeated with more frequency. With the final dataset, we apply the LDA algorithm using two techniques. The first was using a bag of words, and the second is with using the term frequency inverse document frequency. The algorithm must assign the number of topics that you want to obtain. This is a difficult task in reality. And for this, there is another specific rule. We run the algorithm with some numbers until we found consistency with 5 topics. In the figure, we can see the results. Apply the technique of bag of words. We have the topics, these topics, and apply the technique TF, IDF. We have these topics. In the table table 2, we have the definition of topics using one technique or the technique 2. In this case, the results are in Spanish because all the analysis was made in Spanish. and have vida, actualidades, gobierno, noticias, and varios. And apply the technique of TF-EDF. We have justicia, actualidades, noticias, políticas, and variedades. With this,
sorry to interrupt. You've only got 2 minutes left.
Sorry?
You've got 2 minutes left.
Yeah, okay. The conclusions and future work in these papers, the topic used by the most influential Twitter accounts in Ecuador were analyzed to achieve this goal. The last 3,000 tweets were extracted from the 10 accounts with the most followers in the country. The information was preprocessed, and finally the LDA algorithm was applied. To apply the algorithm, two techniques were used, the first using a bag of words and the second using TF-EDF. The results obtained showed that for the analyzed data set is the better to use the TF-EDF technique, since with a greater coherence and words is obtained to form to the topic. The analysis of tweets using LDA algorithm has several applications in this research. The topics shared by the most influential accounts or those with the largest Twitter followers in Ecuador were obtained. Thanks to the results, it's possible to generate marketing relation recommendations to present the main option for product promotion. In this way, it is proposed that future works can analyze the trend of information shared by specific accounts and the press headlines of the country's new media. In this way, the influence of certain opinions on the news could be quantitatively measured. Similarly, future work can use the algorithm to generate the statistics on the reaction of Twitter's users due to the health emergency caused by the COVID pandemic. It is the reference of the work, and thank you.
Okay, thank you very much, George. I'd just like to invite the chair or to ask any questions. And if anyone else has any questions, just to write in the chat, please. I'll hand over to the chair now.
Okay, I have a question. So you have concentrated on Twitter, and you said that in your country is popular, in my country as well. But so I would like to know, is it possible to implement your approach in different social media? So if yes, how to do it? So your algorithm should be modified or not? Could you tell me something more, please?
Yes, the algorithm can be modified for any social media, for
Any
example.
social media, okay, okay.
For example, Facebook, Instagram. The objective in this case, we escogimos Twitter is because the facility of the extract the information.
Okay, I see. Yeah.
Okay.
Okay. Thank you very much. Any other questions from audience? You can write on the chat, please. Okay.
Right. Okay then, guys. If no one has any more questions, we will move on to the next paper, which is going to be presented by Mohammed Rauf Khalfood. And the presentation is going to be linking the linguistic resources using graph structure for multilingual sentiment analysis. Mohammed, I will just unmute you now. All right, I've just requested to unmute you.
Okay. Hello.
Hello.
Hi.
Hello. Hi.
Can you hear me?
Yeah, all good.
Okay. So how can I share my screen?
Down at the bottom in the middle, there should be it should be like a green icon which says.
Okay, I see it. Thank you.
Yeah, cool.
Do you see my screen now?
Yeah, all good.
Okay. So hello, good evening, good morning, and good evening for everyone. My name is Raouf. I'm a PhD student. Today, I'm going to present my work titled Linking the Linguistic Resources Using Graph Structure for Multilingual Sentiment Analysis. This is the plane of my presentation. We will start by an introduction and a problem, and what is the problem, and what we have proposed to this problem, and to see the results, obtained result, and to talk about some discussions. First of all, sentiment analysis is a task that aims to determine the polarity of what people say about the products, persons, events, or anything else. One of the approaches used in sentiment analysis is the lexicon-based approach. It aims to get the word's polarity, either positive or negative. We talk here about a binary classification, or we can classify this opinion in multi-class classification. For example, very negative, negative, neutral, positive, or very positive. The problem tackled here is with the lexicon is there is a lack of lexicon. And we can't find one lexicon that covers many words. Another problem, we can't find a lexicon for each languages. For that, we have proposed to link the different existing resources. But by linking the existing resources, we have faced another problem, which is that the different existing resources use different structure. To deal with that, we have adopted a graph structure. Now pass to the proposed approach. Our proposed approach is composed on 3 steps. The first step is a mapping. In mapping step, we generate the graph from the different linguistic resources. The second step is the generation. In generation, we generate the sibling tokens from the original token. The token here refers to the word. And final step is finding. In finding, we try to find the sibling tokens in the previous generated graph using Dijkstra algorithm and calculate the polarity of the word. Here we can see an example of a graph generated by linking the different resources. As we can see the different words here from different languages linked with 2 types of relation, direct relation and indirect relation. Now I'm going to talk about the 2 other steps, the generation and finding. For example, I will take my original token, the token referred to the word. I use 3 different workers to generate 3 different sibling tokens. After generating my sibling tokens, I will try to find them in my graph. Here, I have found 2 sibling tokens. But which one to use? For that, we have proposed 3 strategies. The first one is by order, or by priority, or by dominance. If I go back here, for example, if I set up the high priority for my first worker here, which is the translator, in the final result, I will take the orange one, this one, this one. And to get the polarity of the word, we have proposed also a new equation, which is based on the crossed path. To evaluate our proposed approach, we have used 5 different linguistic resources. The first one is the Arabic word net, and the second one is the French word net, and the third one is word net. The fourth is sentiment word net, and the last one is MPQA lexicon. The results are promising. Let's start by English. For English, we have obtained a very promising result. As we can see, the accuracy is 0.98. But we can see here that the result differ if we change the labeled lexicon. For example, using MPQA lexicon give more accuracy. For French languages, we have confirmed our previous result as we can see in the accuracy here. For Arabic result, we have noticed a low recall here, as you can see. It's very low, but why? To respond to this question, we did a small investigation, and we have found that the language's characteristics impact the proposed approach. Here, one of the characteristics of the Arabic language is the diacritization. It means that the same word can have different meaning if they have different diacritization. We have tested our proposed approach on Spanish language also. And here what we can get is using different worker. For example, here I have used two different worker. The first one is English and the second one is French. And as we can see, the results are different also. So we can see that using different worker could also change our result. For the last and for the German language, using a rich lexicon such as sentiment word net could affect our proposed approach. As we can see here, the sentiment word net for the accuracy is low compared to the accuracy for MPQA lexicon, but for recall is the inverse. So when you use our proposed approach, you have to good choice the resources used in. Here you can see the different idea to take in consideration to use the proposed approach. We have to choose the labeled words, take the language's characteristics in consideration, choose or not a rich lexicon to enhance the recall or enhance the accuracy, and to choose the good worker for the languages in question. In conclusion, in our work, we have proposed a new approach to create a multilingual lexicon for sentiment analysis to avoid some problems. These problems are lack of lexicons, and creating a new lexicon for each languages to avoid this one, and to deal with multilingual text. We have linked and exploited the different existing resources, such as WordNet, Arabic WordNet, and French WordNet, to construct the graph. We applied a Dijkstra algorithm to find the desired token. And also we proposed an equation to calculate the priority. As you have seen, the results are promising. We got an F1 score attaining 0.82. And for future direction, we tend to take in consideration other parameters such as the word's context and a part of speech tags, and enlarging the graph to be a cross-domain, to be a multi-domain also. The proposed approach, namely Gralexy, aims to find the word's polarity regardless of the language, which is very useful, especially in multilingual sentiment analysis. Thanks for your attention.
Thank you very much for that. I would just like, if anyone has any questions to ask, please do just write them in the message bar, but I'll hand over to the chair for now to see if he has any questions, which I'm sure he does.
So I have a question.
Okay.
You have used Dijkstra's algorithm.
Yes.
Tell me, so is there any weak point of this algorithm in your approach?
We
Weak
have
point?
why we have used Dijkstra algorithm?
Yeah.
Because we using Dijkstra algorithm will help us to find the shortest path between the labeled token and the desired token. If I say it, for example, from the positive labeled node into my sibling token.
So have you tried to?
The shortest path, yes.
I understand, I see. Have you tried to use another algorithm or not? You have decided that just to use this algorithm and you didn't try to use something else?
No, we didn't use another algorithm, but we can use any other algorithm. Yes, yes.
Okay, maybe it could be interesting to compare some.
Yes, it's a good idea just to compare the complexity and the time of calculation.
Exactly.
Yes.
Yeah. Thank you very much.
It's a good idea. Thank you very much.
Thank you for a very nice presentation. Thank you very much.
Thank you.
Right, yeah, thank you very much for that. Moving on, I would like to invite Tatiana Jara to now present her paper, which is the development of an augmented reality application as supporting antenna characterization. I will just quickly, Tatiana, there?
Yes.
Yep, okay, well, I'll hand over to you. Good luck.
Thank you.
Thank you. Hi, everyone. My name is Tatiana Jarakito. I am electronical engineer, mentioned telecommunication. And today I'm going to talk about development of augmented reality application as support in antenna characterization. Authors are Hernan Duy, Luis Guerrero, Paul Chassi, Jorge Ordóñez, and me. We are represented Polytechnic Salesian University and Artificial Intelligence Assist Technologies Research Group. So our introduction is to the statistic provided by the National Institute of Statistics and Census Index of Ecuador. 57% of smart mobile users are young people between 16 and 24 years old, being the main user. These statistics have increased because the study modality in Ecuador changed to a virtual system for the pandemic. The implementation of ICT in the field of learning has become an alternative to reduce the learning curve related to engineering subjects. ICTs are the educational innovation of the moment and allow teachers and students decide change in the daily work of the classroom and in the teaching learning process. In the field of engineering, there are physical phenomena that cannot be represented on a blackboard. So the use of didactic aids such as 3D construction, virtual reality, and augmented reality have generated a platform or mobile application that facilitate learning in students, providing another additional tool to the traditional one. These didactic aids allow the students to have a better visualization. Some universities have created virtual labs with augmented reality, allowing complex visualization and analysis and favoring learning. AI has managed to serve as significant resource in the field of education, but it should not be confused as a total solution that is considered only as contribution to students and teachers. For example, Harvard and Massachusetts Institute of Technology have developed applications with AI in the form of games and labs, implementing groups of programming with which students combine the real environment with the real virtual. In the telecommunication area, the characterization of antennas establishes the main parameters. One of them is the radiation pattern, which establishes the power delivered by the antenna, obtain a 3D model. Currently, there is no tool for the visualization of characteristic parameters of antennas, so this work is in the development of a mobile application for the visualization of the characteristic parameters of antennas based on the calculation and simulation of a resonant rectangular patch antenna and log periodic antenna in band 2.4 GHz. Later, we evaluate the characteristic parameters and obtain the radiation pattern as a 3D model. Finally, the results of the work are observed. Design. The application consists of the characterization of A antennas, monopole, dipole, disconic, parabolic, log periodic, sectorial patch and Yagi wood obtained from the University Telecommunication Lab. These antennas are simulated by ANSYS HFSS software to obtain return loss, VSWR, impedance, directivity, and radiation pattern. For the design of the rectangular patch antenna, we consider the parameters of the table, considering as dielectric FF4, fiberglass epoxy laminate, and in the antenna simulation, the subtract is referred to as 1.5 millimeters thickness with 39 millimeters and length 31 millimeters. These dimensions are obtained using equation 1 and 2 and 3. Figure 1 presents the antenna design with its respective dimension, width and length of the antenna, ground plane, and transmission line. The parameters such as return loss, bandwidth, VSWR, impedance real and impedance imaginary, directivity and display in 2D, and radiation pattern of the gain in 3D are represented in figure 2. For the design of the log periodical antenna, the operating range is 2.4 to 5 GHz, with which some factors are obtained to finally calculate the number of elements using equation 4. Figure 3 presents the antenna design. It consists of 10 elements and principal dipole and a reflector. Figure 4 presents all parameters obtained in the simulation. The directivity is displayed in 2D and the radiation pattern related to the gain in 3D. For the development of application, we need 3 steps. Among the characteristics parameters of the antenna, it was observed that the radiation pattern are 3D models. The process starts from obtaining the radiation pattern from the simulation in HFSS as a WRL file. Later, these files are imported into Blender software that allows the modification of the model, allowing to unit all elements and create one, an extraction of the material. In this case, create a material with the intensity of power of the antenna, that is to say, colors. Finally, the blend files are imported into the Unity software for the development of the mobile application. Unity allows to visualize the material of the model through the vertex color library. This process is repeated for each antenna model. Through before a database with identifier for each antenna is created. In this case, QR codes is chosen. The database is imported into Unity to locate the radiation pattern in each QR. Then the main panel of the application is created. It consists of 4 buttons that allow the visualization of each characteristic parameter of the antenna. In this video, we can see the operation of the application. Using the camera of the mobile device, identify the QR and show the radiation pattern of the respective antenna. Subsequently, the panel with the 4 buttons is shown, allowing the user to choose the parameters to be displayed. This application is compatible with Android and iOS. Conclusion. For the design of the antennas, the real values of the physical parameters of the construction materials must be considered, since these influence the resonance frequency and modify the results in the characteristic parameters of the antenna. With the result of the simulation, the return loss, VSWR, and bandwidth, and within the range of the limits by the impedance required, the application of techniques or for the construction. For the augmented reality in Unity, the Vuforia package is used, which has compatibility with Android and iOS devices since version 11.0. So in Unity as well as Xcode, we need to specify the version. This mobile application provides didactic learning in the field of telecommunication, especially for the students for the subject of antenna theory. since it allows to visualize the energy radiated to the antenna through the radiation path. For future jobs, tests will be carried out with the students to verify the experience when using this tool. This is my reference for this work, and thank you so much for your attention.
Right, thanks for that, Tatiana. I'll just, if anyone has any questions, they could write it in the chat box. And if not, I'll just hand over to the chair to ask you a few questions.
So I have a question. So I've noticed that in your research, you have concentrated on 2.4 gigahertz, but on one slide, I saw 5.0. Could you tell me something more about 5.0? Sorry, can you hear me? Tatiana?
I'm not sure what's going on. It does show that her she's not muted or anything. Tatiana, can you hear me?
Maybe she's not available now. I don't know.
Yeah, I'm not quite sure what's going on. Okay. Right, so as again a response from Tatiana, I will just quick. Is there anybody here who is able to present in Edwin Crucinto's place for the presentation on reference method for loading in web services with RE topology using edge root tools? I'll give it a few seconds, just if anyone says that they would like to present this, if they could just type this in the message box. I'll just give this a few seconds. Right, okay, well, it doesn't seem like anyone is going to be presenting for that one, unfortunately. So what I will do is I'm quickly going to say a few things. Sorry, I don't know what happened there. I got muted somehow. Right, sorry about that. I'll carry on what I was about to say. Just going to make a few remarks, and then after that, if we want to quickly turn the camera on, and we'll get a few messages. Oh, apologies. Give me 1 second. Edwin, I'm really sorry. I realised that you're actually in the call, so we are actually able to present the last presentation, which is by Edwin, on reference method for load balancing web services with REST topology using edge root tools. Sorry about that, Edwin.
Hello, hola, hello.
Oh, yeah. Yeah, I can hear you, all good. Sorry about that.
Okay, moment, please, moment.
Yeah, that's fine. I'll allow you to crack on. Good luck. To start.
Okay, okay, a ver, moment, a ver, voy a presentar. Ahora sí. Ahora sí, y aquí. Okay, hello, hola. Hi, everyone. May you have a good day. I ask for your apologies because my English is not good, but it's a privilege to share the results of our research study developed by Ángel Suyón, Abel Huanca, and myself in International Congress on Information and Communication Technology. The title of this research study is Reference Method, Load Balancing in web services with REST topology using edge route tools. For research problem identification, due to the great demand for information technologies, which generate 83% of web traffic, web services need to function uninterruptedly and stability. Web services with REST topology facilitate scalability and portability, but not stability and performance. There are technologies such as elastic load balancing from AWS, Amazon Kubernetes, DigitalOcean Kubernetes, and Google Cloud Platform Kubernetes, which solve the web traffic problem, but when implementing, they generate certain limitations to the organization. The limitations may be lack of training personnel, dependency on services, on ensure optimal services, and high prices for service implementations. Okay. About the research justifications, 19% of organizations speak the latency of less than 15 milliseconds, while 16% expect a latency of 20 milliseconds or less. To meet this need, the present method proposed in order to reduce the high response time in web services. The reference method arises from the need to reduce the high response time in web services with REST topology, improving their performance and stability. Plus, this method improves the minimal levels required by the metrics of the behavior over time of the internal quality of software for ISO 25,000 and is easily accessible to documentation of the necessary tools for implementations, reducing personnel training and prices. And the objective of this research of this O2 developer of reference method for load balancing in web services with REST topology based in each route tools. The methodology is composed of 4 steps. The first one, web service analysis. The second one is load balancing strategy design. And the third one is development of reference method. And finally, test and analysis of results. In first steps, a web service analysis was made. Service models were identified: entity, task, and utility. All called services abstraction layers. These layers form a hierarchy which help to identify the most reused services. That is, which services receive more or smaller number of requests from web traffic. Load balancing strategy design. In the second step, the load balancing strategy design, the load balancing strategy is to classify resource according to the service model and have a cluster service for each one. This classification was defined according to the usage. of web services abstraction layers. The web service is calibrated for each service model. It is the case of entity and task service model, which are the most reused ones that the utility want. That is, they will receive a great number of client requests. Okay. In the step 3, the referencing method was based on web services analysis and balancing load strategy. This method is composed of 6 smaller steps: resource identification, balancing design, balancing composition, balancing deployment, balancing monitoring, resources assessment. In continuing with the same steps, there are evaluation indicators, maximum response time and services performance. The following metrics were considered for indicators without balancing and with balancing. Next. Okay. Finally, in this last step, the test and analysis of results were made. The test consisted of evaluating the indicators of maximum response time and performance of web services with REST topology of a university enrollment module, a traffic load of 7,575 client requests was tested, which is a total average of a user who accesses the mentioned module. In this way, each REST API randomly consulted the information of 3 different users. The tool's Apache Meteor was used to simulate client requests during 20 minutes per cluster. Applying the proposed method as a first step, we have a resource identification. The resource identification is user info, enrollment courses, enrollment list. The next. As a second step, we have balancing design. A distribution in Docker containers was designed according to service model to represented in clusters. For the utility service cluster, 7 replicas were made. And for the entity and task services cluster, 10 replicas were made. And step 3, balancing composition. Docker was used for dynamic container scaling with traffic image as a proxy in its second versions. Entry points were defined, which are point 18 and 443. Likewise, and red bridge with Docker network was created. To this network, the cluster describers in the balancing design were connected. In balancing deployment, in the step 4, for the deployment, it is necessary to have a cluster server with disponible containers for its balancing, also a number of necessary resources. The balancing deployment.
Sorry to interrupt, Edwin. Sorry to interrupt. You've only got 2 minutes left. So if you could wrap things. Sorry about that.
Okay, thank you. Deployment in this research create an Ubuntu servers. No? And the next, balancing monitoring, the using Docker stats and use execute. and resources assessment, and number and process, and 7,575 and 1,200. Number process, next, utility cluster. The pink line is the result of the balancing of user AP. We can see that responsive time increases compared to the red line, which is no balancing. This happening because the balancing API performance a proxy or redirections to a Docker container. And you results cluster, results of utility cluster and entity and clusters también. Acá, according results and entity and task cluster. According these results, the objects proposed in step 1 were met. We see that balancing REST API have a shorter maximum response time than those which are not balanced. And results indicator results according to indicator, the evaluations of the method by indicator. There are positive results and show in the following in table. And conclusions, as for the conclusions, a 6 steps reference method was developed for load balancing in web services with REST topology based in edge-routed tools, ensuring the reductions of the maximum response time and improving the stability of the 3 web services of the university enrollment module. Considering that carrying out a load balancing increases the average response time and smaller numbers, it was possible to have a greater stability and services by doing replicas of the web services and balancing the traffic load in clusters according to the service model. And reference the main references and of this study there this, and thank you for listening. Thank you.
Right, thank you for that, Edwin. That was a nice presentation. If anyone's got any questions, could they please just write them in the message drop down, and if not, our chair will ask you a few questions.
Okay, so let me ask you. So I saw that you have used in your research upload system. So my question is, this is a cloud computing system in model in infrastructure as a service or something else? Could you tell me something more about upload system which you have used?
Moment. Sistema, administrador. Yeah. Okay. A ver, moment. A ver, moment. Okay.
I saw it on one slide, but I don't remember which slide.
Okay. A ver, voy a compartir. A ver, share it. A ver. Ok, a ver, voy a compartir. Aquí estaba, si no me equivoco. Ok.
Go back, please. Back. Just a moment. Back. Stop. Oh, this upload system. So could you tell me something more about upload system? This is cloud computing system in model IaaS, infrastructure as a system.
Yeah. Ok, a ver, un moment. A ver, and UpCloud is a hosting platform.
Okay.
Technology and max jobs and dynamic resources partitions because facilita, fácil, and implementations, distribution resources in App Cloud.
Oh, I see. I found it. So, okay. Thank you very much for your answer. Thank you. Thank you. Thank you very much.
Okay.
Any other questions from audience, please? You can write on the chat. Welcome.
Any more questions? No, it wouldn't appear so. Right, okay. Well, thank you everyone for presenting. I just have a few closing remarks to make. So I sincerely thank our authors for their excellent presentation and contribution in this session, and all our participants for being a part of the International Congress. I hope this session was informative and knowledgeable as well. Oh, apologies, I haven't got my video on. Hello, I'll continue. All the presenters will be getting their digital certificates through the mail within 2 working days. Further, all the papers have already been forwarded to the Springer. The publication will be live within 4 to 6 months. Kindly cooperate with the team of ICICT 2021 as and when intimated. I also would like to thank our session chair, Mr. Bukolski, for chairing the session. We do actually have a quick little certificate for yourself, just to thank you. There it is, which is a token of our appreciation to the chair on behalf of the team for ICICT 2021 and Global Knowledge Research Foundation. Thank you for your presence. Before we end the meeting, if I could just kindly ask if everyone could quickly just put their cameras on, just so I can quickly take a picture, just so for the for our meeting, if that would be okay. Yeah, if everyone could just briefly put their cameras on, and I'll quickly take a screenshot. Then that will perhaps be on the website. So I'll give everyone like 30 seconds, a minute or so, just to get their cameras on. Oh, getting a few more faces. Any more? Oh, there's one more. Come on, guys. Nope. Well, it looks like that is going to be it. Right, I will quickly take a screenshot. Right, I've got the screenshot, guys. So thank you all very much for your participation. I hope you had a good time. That is all for this meeting. Is there anything anyone would like to say, or doesn't appear so? Right, okay, well, thank you, everyone, guys. Thank you, everyone.
Thank you.